Hello, my name is Francesca Ballesteri, and this is my exam mini video for Module 6. In prokaryotes, there are four modes of transcriptional regulation: negative inducible, negative repressible, positive inducible, and positive repressible. I'm going to be focusing on the last one, positive repressible, in this video. What does positive repressible mean anyways? Well, positive control indicates that an activator binds to DNA to stimulate the transcription of structural genes. Structural genes are the genes that code for proteins. Repressible control means that transcription is usually on, but gets turned off when a small molecule binds to the regulatory protein. Putting all this together, positive repressible means that the activator is usually bound to the DNA, allowing transcription to occur, but when a small molecule is present, it can no longer bind to the DNA, causing transcription to stop. Well, what does this look like? Well, it starts with an activator gene being transcribed and its RNA product being translated to form an activator protein. This activator gene can be close to the structural gene, or it can be thousands of base pairs away. The activator then binds to an activator binding site upstream from the structural gene on the DNA. The activator being bound to the DNA serves as a signal for the RNA polymerase to transcribe the structural gene. Therefore, when the activator is bound to the DNA, the gene is expressed in the positive repressible mode of transcriptional regulation. Now what happens when a small molecule is present? Well, the small molecule, shown in black, binds to the activator, changing its shape. Because of this change in shape, the activator can no longer bind to the activator binding site. Since the activator protein isn't bound to the DNA, the RNA has no signal to transcribe the structural genes. Because of this, if a small molecule is present, the gene will not be expressed in the positive repressible mode of genetic regulation. This can be a little confusing, so here's an analogy to help you wrap your head around it. Arthur's a very studious little aardvark. He usually gets the bulk of his homework done while his sister DW is at the park with her friends. However, DW recently got a new radio. Now, instead of going to the park after school, she stays home and listens to her radio. Now that DW has his radio, Arthur can't concentrate, and therefore cannot complete his homework. In this analogy, DW is the activator and the park is the activator binding site. When DW is at the park, Arthur, who represents RNA polymerase, can do his homework, which is a gene product. Essentially, the act of him doing his homework is analogous to the RNA polymerase transcribing the gene. The radio in this analogy is a small molecule. When DW gets this radio, she no longer stays at the park, making Arthur unable to concentrate and complete his homework. This is analogous to the activator protein no longer being able to bind to the DNA once it binds to a small molecule. Since the activator isn't bound to the DNA, the RNA polymerase can't transcribe the gene, and the gene is not expressed. And that's positive repressible transcriptional regulation in a nutshell.